Okay, so in this example, we've got sodium thiosulfate, and we've been given its mass, hydrated, as well as the mass of the anhydrous sample. And we need to use the information we've been presented with to work out the value of x, right? So we need to figure out what's the coefficient associated with the H2O. And the way I'm going to approach this, what I'm going to do is I'm going to try and work out what's the number of moles for the sodium thiosulfate in its anhydrous form, and what is the number of moles of the H2O present. So and in effect, I'm going to approach this using the fact that the number of moles N is equal to the mass divided by the molar mass, and then later on we'll do some ratio stuff. So okay, so in this case, the number of moles for the Na₂S₂O₃ is going to be the mass divided by the molar mass, right? So that's going to be 8.43 divided by the molar mass. Now the molar mass, we can work that out from the periodic table. So I mean, there's actually no need to have that twice, but since it's up here. But anyway, that's effectively, so MR of Na₂S₂O₃, right? So that's going to be, so for Na2, that's going to be 23 times 2 plus 32.1 times 2 plus, for the O3, that's going to be plus 3 times 16, right? And so that's going to give us the molar mass, right? And in this case, that's going to give us 158.2, okay? And that's going to, the units for that's going to be in grams per mole. All right, so 158.2. And if you do have a go at working that out, what you should find is that you get 0.053287, right, in moles. And when we look at the we've got now kind of the left hand side, right? So the Na₂S₂O₃. We also need the right hand side, which is the H2O component. Like, what's the number of moles of that? And so if you look at that now, so the number of moles of the H2O is going to be, well, so we need the mass divided by the molar mass, right? So so if we concern ourselves with the mass of H2O, what we need to do is effectively, this mass here is effectively the mass of both, the Na₂S₂O₃ and the H2O aspect. This is the mass of effectively Na₂S₂O₃ without H2O. So if we want to kind of figure out the mass of the H2O, all we need to do is get the, effectively 17.43, the hydrated mass, and subtract from it the effectively this component, right? So which is amounts to 8.43, right? And so that's going to be 9 grams, right? And therefore, if we're looking at the number of moles of H2O, and I'm going to just move this slightly just for the sake of clarity. When we're looking at now the number of moles of H2O, we can say that that is going to be equal to the mass, so the mass M9 divided by the molar mass. So for H2O, of course, the molar mass is just going to be, so for hydrogen it's going to be 1 and then times 2, so that's for the H2 aspect. Plus the oxygen component, 16, right? And that's times 1, right? So I'm just going to leave it like that, plus 16. And that's going to give us 18, right? So that's going to be 18 grams per mole. Okay? So with that 18 now, and using the equation, we're going to get, I mean, that's basically 0.5, isn't it? So 0.5 moles. Yep. Okay, so with both of these values in mind now, remember what we're really trying to answer is the question of for every 1 mole of Na₂S₂O₃, how many moles of H2O do we have, right? So what I'm going to do is I'm going to make a side-by-side comparison. I'm going to put the Na₂S₂O₃ aspect on the left-hand side to make the comparison a bit more, more comprehensible, let's say. So effectively, N of Na₂S₂O₃, ratio of number of moles of H2O, it's effectively going to be 0.053287, 0.5, right? And that is effectively, well, what we're going to do at this stage is, the question, as I said again, is concerning 1 mole of Na₂S₂O₃, right? So we want to get this value on the left-hand side to be 1, right? So how are we going to do that? Well, the straightforward way to do that is to divide it by itself, right? So if you divide this by 0.053287, that's going to give us 1, right? Because we are dividing it by itself. Now, this is a ratio, which means that what we do on the left-hand side, we also do need to do on the right-hand side. And so we also need to divide this by the same. So we need to divide it by 0.053287. Okay, so you can have a go on a calculator and try and figure out, well, what's that going to give us, right? Now in this particular instance, that's going to give us 9.3832. Okay, and what I'm going to do is we need to bear in mind that we are looking for an integer value, right? For x, and given that, what I'm going to do is round this to the closest integer value. Now 9.38, what's the closest integer value? Of course, in this case, it's going to be 9. Okay, so we can say that that one is in a ratio with approximately 9, right? So we rounded this to an integer value, and so therefore x, right? So therefore x is equal to 9. Okay. And so what are the implications for the formula? Well, simply that means the formula is now going to therefore be Na₂S₂O₃, 9H2O. Okay, so above, as you see where it says enter your answer, effectively what we need to put here is a 9. Okay. Yeah, so yeah, that's how you'd work that out.